All right, so here we have another limit, and again, we're going to follow our strategy chain for limits, starting with direct substitution. If I plug in 3 into the expression that's here, I get 3 minus 3 on top, and I would get the square root of 4, which is 2 minus 2 on bottom. That's 0 over 0, that's an indeterminate form. Our strategy we learned in the last video was factoring and canceling, but that works when you have polynomials on top and bottom. Here I have a radical on the bottom of my fraction. So whenever you have a radical on the bottom of your fraction and you get 0 over 0, the strategy is going to be to rationalize the numerator and denominator. Now, rationalizing means multiplying something by the conjugate to get rid of the square root in a certain location. So my radical is in the denominator of my fraction. So what I'm going to do here is I'm going to multiply the top and bottom by the conjugate of that thing, which basically means the square root, change the sign in the middle, and then the other thing. So I'm going to do that to the top and bottom, because in order to keep a fraction from changing value, you have to multiply the top and bottom by the same thing. Now, I want to point something out here. When I plugged in 3 at the top, I got 0, right? Because I had a factor of x minus 3. When I plug in 3 in the bottom, I'm getting 0 as well, which means at some point in this manipulation, I'm going to get an x minus 3 on the bottom. So we're sort of looking for that when we go through this process. So what I'm going to do is I'm going to go ahead and multiply out the denominator. Now when you do this, when you multiply conjugates by each other, you get a difference of 2 squares. So instead of having to multiply everything out, really what I have to do is think about squaring that square root, multiplying it by itself, which would give me x plus 1, and then minus squaring that last part, because if I were to FOIL it out, the middle things would go away. So that would be 4. Now, this is really important, so listen when I say this. You want to multiply the parts out where the square roots will go away. You do not want to multiply out the other thing. And I'll show you why in just a moment. So I'm just going to write on top of this what I get when I multiply them, but without multiplying it out. Now remember, we were expecting an x minus 3 factor to show up. And if you look on the bottom, that x plus 1 minus 4 is x minus 3. So that thing that was going to cancel, like it did in the factor and cancel thing, is now there. The x minus 3's will go away. That's why you don't want to multiply it out, because you need to cancel that thing and you need it to be separate in order to do that easily. So now that I've canceled out what I call the offending factor, I can go ahead and do my direct substitution again. So I'll show my step here where I canceled it out so it's clear what I did. And now I'm going to do my direct substitution. So when I plug in 3 for x, I get the square root of 4, which is 2, plus 2, and that's 4. So that would be the value of the limit. So when you have 0 over 0 and you have a square root involved, multiply the top and bottom by the conjugate and make sure you only multiply out the thing where you're trying to get rid of the square root so you can cancel appropriate.